Hey everyone, welcome back to a new year. Here we're going to start Unit 4, which is on quadrilaterals, our four-sided figures. So looking at this first page of your packet, it says quadrilateral properties. And down the left column, we have the parallelogram, the rectangle, which is our notes topic for today. We're going to do both of those shapes. The rhombus, the square, we're going to do next class. Then we have the trapezoid and the isosceles trapezoid. So this first page we're going to come back to a little bit later. We're going to kind of fill this back in. This is like your cheat sheet with all the rules kind of all in one place. What I really would like to focus on to start today is the next page. Okay. So if I rotate our paper and scroll us down, here we go. We have the quadrilateral family tree. There it is. So our quadrilaterals are our four-sided figures. They have four sides, and they also have the sum of their angles being 360 degrees. Now, this top shape and all these little arrows, there's one missing right over here, are going to be kind of how the family tree flows. So think about your family. You have grandparents that have some sort of cultural background that they share with you if you're Irish, Italian, so on. They kind of pass down those traits, the freckles on your face, if you can curl your tongue or not, right? Your dominant genes, your recessive genes, the color of your hair, all different things. So that's the same idea here with this quadrilateral family tree. Up at the top, here we have Papa Quadrilateral. He's up at the top of the tree. I'm going to say Papa Quad. Right? So Papa Quadrilateral is up at the family tree. He shares the fact that he has all four equal sides, or I'm sorry, not four equal. Sometimes they're all equal, sometimes they're not. And that's a trait that we learn as we go down the family tree. But Papa Quad has four sides, and the sum of his angles are always 360. Then we have the kite, which is over here to the left. We have a parallelogram. We have a trapezoid. Now, the difference between all three of those branches is that a kite has no parallel sides. A parallelogram has two sets of parallel sides. And apologies for my handwriting on the screen today. It's the best case I got. So we have two sets of parallel sides. So the top and the bottom here would be parallel. The right and the left would be parallel. And a trapezoid has only one set of parallel sides. And then those traits are shared with every generation underneath it. So we have the kite, the parallelogram, the trapezoid. Anything true about the kite gets shared with the rhombus. Anything true about the parallelogram gets shared with the rhombus. And anything true about the parallelogram also gets shared with the rectangle. So we're going to talk about all these relationships a little bit later. But again, today I would like to focus here in the middle on the parallelogram. Okay, so here we know opposite sides are parallel. So for a parallelogram, there are going to be 5 different properties or rules, and we're going to apply those rules to solve some problems in a minute and also do some proofwriting. So we have opposite sides are parallel. Opposite sides are also congruent in measure. So that's my little squiggle there. So if I knew, I'm going to erase a little bit of my picture here. If I knew this length of the side here was 12 feet, then this parallel side down here would be 12 feet. If I measured this to be 8 feet, then the left side would be 8 feet because opposite sides are congruent. So those first two little facts are about the sides. The next two here are about the angles. We know that opposite angles are congruent. So if I go in and I tell you this angle here is about 60 degrees. I used my protractor and I measured it. That angle would be 60. Just going to take out those arcs because they're not very curved. Here we go. It's opposite angles are congruent. So if that angle is 60, then up to the right top corner would also be 60. Okay. The next little fact about about a parallelogram is its consecutive angles are supplementary. Now, consecutive, remember, means one after the other. So if I were to label this parallelogram, if I start here, knowing that angle A was 60, as we label our shape, we have to go clockwise around it or counterclockwise. So ABC is going to be opposite the A, and D is up to the left. Okay, so if we have this parallelogram ABCD, the consecutive angles would be angle A and angle B are supplementary. So if that's 60, 180 minus 60 gives us 120 degrees. Remember, supplementary means they add to 180. Well, if that angle is 120, then its opposite angle is 120. And what will 120, 60, 120, and 60 add to as all four angles? 360 degrees, which is a fact that we got from Papa Quadrilateral right above this. Okay, so again, we have opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. And last but not least, let's talk about the diagonals. So the diagonals bisect each other. And I'll explain what that means. So if I drew a new parallelogram, I'm going to kind of zoom in and draw a nice little one here. If we drew a nice parallelogram, okay, and drew in two diagonals, a pink one, let's see this orange one, what's going to happen is each of those diagonals are cut into equal pieces, meaning from here to here and here to here are of equal measure. So if that whole diagonal measured 12 inches, this would be 6 inches, and this would be 6 inches. The opposite direction, this diagonal is broken into two equal pieces as well. Okay, so if that diagonal is going to measure something shorter, right? So the first diagonal with this corner in pink and this right hand top corner in pink, that measurement, let's say we called that AC, and we have point E in the middle, we know that AE would be congruent to EC. And the opposite direction, yes, that's a plane outside my window. I live near an airport. BD is the other diagonal. We know that B to E as going to be congruent to DE as a segment. That this and this are equal, that and that are equal. So that's the last little case there for diagonals of a parallelogram. They bisect each other. So these are 5 facts that we have to know about our parallelogram. We're also going to be working on the rectangle today. So those 5 rules are also true of a rectangle. Its opposite sides, this side and this side, are congruent. That side and that side. Its opposite angles are congruent. But something else is added in with the angles. A rectangle is a parallelogram kind of just tilted back up 90 degrees. So if you imagine a parallelogram here, okay, and you take this side and you kind of move it so it's a little bit more straight. So this angle here becomes 90. That becomes your rectangle. So the facts about that parallelogram are also going to be true of the rectangle. Its opposite sides are congruent, opposite angles. Consecutive angles do add to 180 because isn't 90 and 90 going to be 180? And 90 and 90 would be 180. Diagonals do bisect each other, but now this diagonal and the measurement from this diagonal are also going to be equal. So there's 2 facts added in for the rectangle. So that's what this 5 plus 2 means. It means the 5 rules from the parallelogram are added in, and all angles are 90 degrees. And the other new fact is that diagonals are congruent in their measure. So that means if this first diagonal, Sorry, I know I keep erasing things, but it's really for explanation purposes. And now another plane's coming in for a landing. One diagonal and this other diagonal, if I were to label this R, E, C, T for rectangle, right? We know that RC as a diagonal would be congruent to ET as the other diagonal. All right. So those are the two shapes we're going to focus on today. I need to rotate my page kind of back. And we're going to flip to the next page of notes. Okay. So again, this is very repetitive. Again, I feel the more we see it, the more we understand it. A quadrilateral is a four-sided figure. Trying this again. Angles always add to 360 degrees. In a parallelogram, opposite sides, like DC here and AB here, are going to be congruent. Opposite sides are also going to be parallel, meaning those run in the same direction, left to right. These kind of run in a northeast fashion, left bottom to top. Next case is that opposite angles are congruent. So in this picture, we can conclude that angle A would be congruent to angle C, and we know angle B would be congruent to angle D. Now, those congruent statements we're going to be using in proofs here in a minute. I say a minute. I think I moved it to another day of notes, so it's probably going to be next week. In the parallelogram, consecutive angles are supplementary. Okay? Meaning, if angle A here is teeny tiny, let's say that's 20 degrees, 180 minus 20 gives you angle B to be 160 degrees. And last but not least, diagonals bisect each other. So those are the first 5 most important facts about a parallelogram. All right. I am going to use the second picture again to draw in those diagonals. So if I have diagonal AC intersecting diagonal BD at a point, let's call it E, then we know that A to E would be congruent to EC, and also DE would be congruent to BE. Right? So those little parts are equal to each other. So again, AE and EC are equal, DB and BE are equal. Now notice those measurements are a lot different. Like this orange length from A to E is a lot longer than B to E is, I'm sorry. Adding in those properties of the rectangle. So again, all the properties of the parallelogram fall into place here. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Just going to keep bisects for timing today. Plus 2 more. So the 2 new rules about these rectangles is that all angles are 90 degrees, or all angles are congruent, and diagonals are congruent. All right. So those diagonals, I don't know why I put the parentheses in. Sorry about that. So the diagonals being congruent, they're also bisected. So these 2 facts about the diagonals tells us that AC as a whole length from A to C would be congruent to BD as a whole length, and it's bisected. So AE and EC are equal. Same with DE and BE are equal. So with that idea, we know that AE is congruent to EC is congruent to BE, is congruent to DE. So you actually have 4 equal segments there. So if I told you the length from A to C, if we measured it and it was 20 yards, all right, then AE would be 10 yards long. EC is 10 yards long. This would be 10 yards and 10 yards because these are equal and they're cut into 4 equal pieces. Okay. So those are a couple facts about our rectangle and our parallelogram. Applying those facts. So applying those properties, we're going to look at some algebraic examples. Exercise 1. Given the parallelogram below. So they have to tell you it's a parallelogram. That gives you all those rules about it. Find the measure of angles 1 and 2. Well, we know opposite angles are equal. So I'm going to write in this little box here, opposite angles are equal. So we know angle 2 is going to be 75 degrees based on that 75-degree angle given to us. But another fact that we know is that consecutive angles, if I can write today, sorry guys. Consecutive angles are supplementary. So what that's going to tell you about this picture is that this 75-degree angle and the angle next door to it, angle 1, equal 180. So 75 plus angle 1 equals 180 degrees. So when we subtract that 75 over, angle 1 is 105 degrees. So now we found the measure of both angles using 2 different rules. Opposite angles are equal and consecutive angles add to 180. We're going to apply the same kind of idea to exercise 2. But the problem with exercise 2 is there's a really big blank space here. Okay, this blank space, we need to draw a picture. Okay, a lot of you are going to try to look at those numbers and just go, oh, I add to 180. But we really have to draw out the picture and see what this parallelogram looks like. So here we have parallelogram help, H-E-L-P. So what we're going to do is we're going to draw a parallelogram. And please, as you're drawing it, you have to label it correctly. So it doesn't matter what corner you start in, but you need to go around the shape, H-E-L-P. So you notice I didn't skip any corners. I started at H, I went to E, I rounded the corner L, and came back to P. Because the order of there tells me that H and the L are opposite each other because it's the first and the third letter. So that means the H angle and the L angle are the obtuse ones. And, or acute, I don't know about the measures. And the E is going to be equal to the P. So if the H angle is measure of angle H, here is represented by 2x plus 10. I'm going to kind of type that in. 2x plus 10 is the H angle. And angle P down here is going to be 3x, okay? Those two angles fall next door to each other. So we know that angle H plus angle P equals 180 because these angles are consecutive angles. It's not opposites here. So the rule we're going to use here is that consecutive angles equal 180, right? So we're going to take the 2x plus 10 and add it to the other angle. So we're going to take the 2x plus 10 plus 3x equals 180. Combining like terms, we have 5x plus 10 equals 180. Subtract our 10 over, 5x equals 170. And if we need to calculate that out, 170 divided by 5 is going to give us that x equals 34. So now we know we're not done yet. We have to go back in and substitute in the measure to find out what we're looking for. So again, rereading the question, in parallelogram help, Angle H is this, and angle P is this. We marked up the picture. Find the number of degrees in angle E. So looking for angle E is here, okay, which is opposite angle P. So we're going to take 3 times the 34 to get our final answer. So there we get 90 plus 12 more is going to be 102 degrees. Now that's not necessarily drawn to scale. So again, I'm just going to triple check myself here. 3 times 34 does give us 102. This diagram, it ends up not being to scale. I probably should have kind of shifted where my 4 letters were. But either way, when you draw pictures, sometimes they're going to be drawn to scale for yourself, sometimes not. You really have to just go with the facts. Okay. Exercise 3. Given parallelogram ABCD. Now let's see if in my shapes I have a parallelogram. I guess not. So we're going to go based on another nice drawing from this log. Okay. So here is our parallelogram, really badly drawn. That one's a little bit better. So given parallelogram ABCD, diagonals AC and BD intersect at E. So if I start down here this time, ABCD, A to C is one diagonal, B to D is the other, intersecting at a point E. If AE is 3x minus 4, so we're going to type here 3x minus 4, is one part on the diagonal, and EC is x plus 12, okay? AE and EC are 2 parts along the same diagonal. So here we know diagonals are bisected, meaning they're cut into 2 equal sections. So we can conclude that AE equals EC. So 3x minus 4 equals x plus 12. We're going to subtract our x over, we get 2x. Add our 4 over, we get 16, making x 8. Okay, so I know solving wise, you guys could do that fine. But now we have to make sure we go back in and answer the question. Find the length of AC. Well, AC is that whole diagonal. So if we put our 8 back in, 8 plus 12 gives us 20 here. Well, 3 times 8 minus 4 would also give us 20. So we can conclude as a final answer that AC equals 40, because 20 plus 20 will give us 40. So again, sometimes, we don't stop at our x value. We have to sub it back in. Exercise 4, our shape changes. Now we're going to be talking about a rectangle. So looking at exercise 4 here. If the longer side of a rectangle is 8 centimeters and the diagonal is 12 centimeters, find the length of the shorter side. So if we have a rectangle with a diagonal drawn in, the longer side of a rectangle, so longer side of the rectangle is 8 and the diagonal measure is 12. Well, something we know about rectangles is that they have right angles. With that right angle, we also now have right triangles. So if this measure on the longer side of the rectangle is 8, the diagonal is 12, and we have to find the shorter side, x, we're really looking at right triangles here. So our Pythagorean theorem is going to help out. So we're going to use a squared plus b squared equals c squared. Remember, 12 is the hypotenuse here. It's the diagonal. So we're going to have x squared plus 8 squared equals 12 squared. X squared plus 64 equals 144. Subtract your 64 over, x squared is going to equal 80. So let's try that. So 144 is 12 squared minus 64, which is 8 squared, gives us 80. Now, it doesn't ask you how to round this. So what we're going to do is take the square root of both sides. Square root of 80 is very close to 9. So x is going to approximate to 8.9. Because remember, square root of 81 we know is 9. So if we type this in our calculator, second x squared of 80 will give you about 8.944. So we're just going to kind of leave it at that. If it asks you to round to the hundredths or to reduce your radicals, we could have, but we're going to kind of move on to the next question. Exercise 5, another rectangle. So given rectangle ABCD with diagonals AC and BD that intersect at E. So if we have A, B, C, D, and again, please make sure you go all the way around your shape because A and C should be opposite each other, B and D meeting at a point E. And they give you, continuing, the measure of angle ABE, ABE is 38 degrees. Well, a couple things about this rectangle. We know that this whole angle at A is 90, this whole angle at B is 90, this whole angle at D is 90, this whole angle at C is 90. What they're asking us for is ABE. So remember, we trace from A to B to E is the opening at the top part here. So it's this acute angle here. Now the whole angle, remember, is 90, but this teeny tiny little piece is going to be 38 degrees. What they're asking us for is to find the measure of angle BCE. BCE is this part of the angle. Okay. So one thing we're going to know is, or two facts actually we're going to use here, is that our diagonals are equal and bisected. What that gives you is that these four pieces are equal. So therefore, this triangle that we're trying to find an angle for is isosceles. All right. The other fact that we're going to use is that the angles equal 90 degrees altogether. So if we take 90 and subtract the 38 degrees that we have, 90 subtract our 38, we're going to find 52 degrees. Well, if that angle is 52, this navy blue triangle I've been tracing here is isosceles. So that tells me this angle we're finding, this angle BCE, is also going to be 52 degrees. Okay, so that's going to be your final answer here. So again, you really have to pay attention to what you're drawing in these diagrams and what you're labeling. Okay, so the whole point to this course is to really pay attention to those details. Okay, questions 6, 7, and we do have some proofs. I believe I'm going to skip the proofs for today so that you can try the classwork. Okay, so your classwork has about 9 questions total. There's some mixed review questions there. But I am going to skip through a couple of these proofs. I'm going to come back to those next time because we're getting a little long on our video today. But number 6 is going over the properties of all rectangles. So we have to remember a rectangle has 7 rules true about it. Its opposite sides are equal. Its angles are 90. Opposite angles are equal. Consecutive angles add to 180. Diagonals are congruent and bisected. I should put 3 dashes across each of those because they're different measures than the other pieces. But which of the following is not a property of all rectangles? Both pairs of opposite sides have equal lengths. Well, that's true. If this is 18, this is 18. If that's 10, this is 10. That's a true fact. All angles are congruent. Well, all angles are 90 for a rectangle. So that is true. So again, we're finding what's not rule. Diagonals are congruent. Well, that was a rule we just said, that this diagonal and this diagonal are equal. Diagonals are perpendicular. Now the deal here is, are those two diagonals making right angles in here? Is this angle here 90 degrees? It's not, okay? If we shortened up the rectangle, made it more like a square, that will be true. But in this rectangle, all rectangles, it's not true. All right. So really knowing those rules, those 7 rules that we were starting at the beginning here, opposite sides are congruent and parallel and supplementary, is going to help you for those type of multiple choice questions. Okay. Question number 7 is also applying those properties. Parallelogram hand, H-A-N-D, diagonals meet at point S. Which statement is always true? HN equals a half of AD. Well, AD looks really long. HN is the other diagonal. Those two diagonals don't have anything in common, so it's not going to be choice 1. AS is short. Is that half of anything else? It's not. All right. So AS is the shorter one, but AS equals a half of AD. Let me go back to that. Let's put some measures in this picture to make it make sense. Now, these numbers I'm pulling out of thin air. Let's say that this is 8. This would be 8 because that diagonal is cut into 2 equal pieces. So I know that AS is 8, and they're also looking for AD here. AD is 16. Is 8 equal to a half of 16? It is. All right, there we go. So I misspoke a second ago as I was reading this. I was looking at it a little funny. But AS, this half a measure, small piece, is half of the whole measure. Now again, that 8 and the 8 I made up. I just pulled an even number out of my hat. 8 and 8, I put those in the correct positions that would be equal to each other. When you add them, you get 16. So that's a little strategy to help with some of those multiple choice questions. Proofwriting. I'm going to skip for today. All right. So proof 1, proof 2, proof 3, we're going to come back to those at a different time. Here's our classwork for today. I'm going to do the first 2 proofs with you because it really reiterates some of the important pieces. So complete each of the following problems. Remember which properties are needed to answer the questions below. So given this shape is a parallelogram, when you're given it's a parallelogram, you know 5 facts about it. You know this side and this side are equal, this side and this side are equal. You know these are parallel, and these sides are parallel. You know that this angle and this angle are equal, this angle and this angle are equal. You also know that this and this are equal because they're bisected, and you know this one and that's equal. So all of those things are true. Now, I don't expect you to draw that in every single time you do this question, but those facts you have to have rolling through your head. So again, opposite sides are equal. Let's type this out for a second. You know, opposite sides are equal and parallel. You know, opposite angles are equal. You know, consecutive angles add to 180. And you know, diagonals bisect each other. Okay, so those 5 facts, again, the first 2 I kind of lumped together in that first statement, but those 5, stop. I don't know what my mouse pad was doing there. Sorry, guys. There we go. So those 5 rules are true. All right. So looking here, if it's a parallelogram, why would PQ be congruent to RS? So PQ and RS are congruent because they're opposite sides. So this is going to be a little 2-step mini proof. If you're given the fact that it's a parallelogram, then we can call these sides PQ and RS congruent because comment textbook, sorry guys. In a parallelogram, opposite sides are congruent. So that's a reason in our proofs now. So again, those properties that we were doing on the page a minute ago, right? These bullet points here, okay, on this first page, and also we're going to come back to it here on this front page. Opposite sides are congruent is now a reason in our proofs. Exercise 2, or part 2. Given ABCD is a parallelogram, why would AB be parallel to DC? Well, AB and DC are opposite sides. So what we're going to say here is that we're going to conclude AB is parallel to CD or DC. And the reason is because in a parallelogram, opposite sides are parallel. Just going to use a double L to show the parallel symbol. Right? So those reasons, those statements I keep saying, those properties, we're going to be using time and time again. Okay. Exercises 3 and 4 are very similar to problems from a minute ago from the notes page. But remember here, opposite angles are equal. So 9y would equal 135. If I help you with some equations here. So exercise 3, I'd like you to draw your picture, decide what to do with angles A and B. Okay. Exercise 4 usually throws people for a loop. 9y, I can even write right now, 9y would equal its opposite angle, 135. So you can solve for y there. But also consecutive angles, the 135 and the 5x, those are next to each other. Those add to 180. So 5x plus 135 equals 180. So again, sometimes you're going to set the parts equal depending on their position in the picture. Other times you're going to add them together to equal 180. Just want to double check. That is a 5, yeah. Okay. So there you can solve for x and you can solve for y. Number 5, remember consecutive angles are supplementary, should help you with that. So again, making that decision to set things equal, or in this case, to add one thing to the other to equal 180 is the idea we have to kind of set true. Number 6 is a multiple choice practice. 7, I have a little reminder here to help you with. And 8 and 9 are mixed unit 1 review. We do have a midterm coming up in the next few weeks, so we really need to kind of practice those ideas. So I'd like you to make sure to try those. So again, if you could be finishing here, classwork 4.01. I did first couple with you. Right? 3 and 4 I kind of helped you out with, and finish through question 9. Thank you.